If you're an engineer and you're looking to improve productivity, then look no further than this week's show, because we're taking this part from 6 ops down to 1.
So this particular component was made on a 3-axis machine tool using a vise. It had to be set up 6 times. It had to be programmed 6 times. It had to be inspected 6 times. The tooling for each operation had to be set up 6 times. The downtime on the machine tool was excessive. Now I'm going to go and speak to Billy to find out what improvements he's made and how he's currently manufacturing this part.
So we've gone from 6 operations to 1. We've got a new machine, 3-axis machine with a 5-axis rotary table on. We've improved our tooling strategies, and we're also using a RoboJob system to be able to get us off in 1 operation. So with the Nikon rotary table, it allows us to rotate the part in the machine and allows us to kit each single face, so then we can finish it off and flip it for an op 2.
So this is where we are so far. The robot loads the raw billet onto the 5th-axis rotary table. The work holding also plays a crucial part, holding on just 3mm of excess material. All 5 sides are now presented to the spindle and are fully machined accurately. The robot then picks the component out and puts the component onto a turnover station. Then the component is reloaded at a later stage and finished, all complete in 1 operation.
So we found out how it's machined, but I wanted to know why they chose a 3-axis machining centre.
The reason we didn't go for a full simultaneous 5-axis is because our work doesn't really require it. We can still use our machine for a normal 3-axis and still have the capability with the Nikon rotary to do a 4+1 job.
The Doosan DNM 6700 3-axis machine provides great flexibility with a large working envelope. The addition of the Nikon 5th-axis rotary table and shunt-centric gripper mounted to the right-hand side means they still have space for a vise on the left-hand side for the last milling feature of the process, and it's proving to be a great solution for this job. Now, let's talk cutting strategies.
Before, we was using a very conventional style of milling. We was taking a small depth of cut and slower feed rates. So with the improvement of Mastercam, we've managed to develop a dynamic / trochoidal way of milling, which makes us be able to use the full entire flute length with very small radial cuts, which means we can get a lot faster feed rates, which reduces our cycle time significantly. With Mastercam, we've also included the probing cycles. So then all the probing's done through Mastercam and it's ejected with the program onto the machine.
Trochoidal milling is a method of machining used to create a slot wider than the cutting tool's cutting diameter. This is accomplished using a series of circular cuts known as a trochoidal toolpath. The cutting tools and holders also play a key role in this cutting strategy. Let's get educated on trochoidal milling. This educational video is courtesy of Hoffman Group UK.
Because of the variability of AE, we can now revise the formula as follows. So, from now on, it's the average chip thickness HM that is constant. Modern CAM systems and controllers now use the constant value of the average chip thickness, that is HM, to calculate and control the optimum milling path, thus ensuring maximum machining efficiency.
You can see the cutting tool paths clearly on this Mastercam simulation, and you can see that now all of the 5 sides of the component are presented to the spindle.
So the cutting tool strategies have obviously played another big part in this process. further reducing the cycle times of this application. Not only the cutting tools, but the cutting tool holders. This particular one being a hydraulic holder to clamp the end mill securely. But have they made any improvements in inspection?
Well, if we go back to previous machining on the old system, where we were inspecting 6 operations, 6 different times, 6 labour-intensive movements into the quality area, we've vastly improved that now, bringing it over to the robotics. We are now doing our first off the machine when the component is fully produced. The operator will go to inspection, would do 1 operation, 1 inspection, and then the machine thereafter is probing dimensions throughout the batch, correcting adjustments, making adjustments, doing corrections. So thereafter we know that those parts on that bed of that machine are correct. There is no further inspection. It's a deburr on the machine operation. There are no sharp edges, no burrs. We take the parts off the machine and we take them to the assembly plant.
You mentioned there about in-process measurement, but how does it all work?
The system works where the tool will come in and cut the material, and then there's a tool probe. So thereafter, when that tool's done the cutting job, the probe will come in to the section area and it will measure the bore of the hole, for instance. And if anything needs adjustment on that size, the machine will automatically tell the tool compensation to make that adjustment. So when the next tool comes down thereafter on the same operation, it will be adjusted and everything will be correct.
Don't forget, you too can win a Swarf and Chips goodie bag if you can guess how long it took to make this part. And you've had a few clues throughout the show. It did previously take them 63 minutes. So put that guess in the comments box below. Look, you've learned that the savings for this company have been astronomical, but it's not for me to tell you. It's all about their production director, Darren.
Well, it speaks for itself really, doesn't it? I mean, 6 operations to start with, cut billets being moved from the saw to areas, the labour intensity of loading machines, the cost saving of the person, the operator, the skilled engineer. We're now loading and loading once. The machine is going to pick everything up, make all the adjustments, cut the material, give us the parts we want at the end of the day, and we can take the finished product over to our assembly lines. Everything's just so efficient and our capacities are freed up. Well, it's helping me immensely. I'm able to quote for new customers, I'm able to bring new work in, I'm being more competitive on pricings. We're seeing the subcontract side of the business have some growth. We want new people to come on board, but we're just effective. We're on time delivery. Our lead times have improved immensely. So overall, it's a massive investment that we're really pleased with.
It's been a real pleasure being at Hydrafeed today. I've learned so much and I hope you have too. Don't forget to like, comment and subscribe to the show. And as we always say, keep those spindles turning.